You hear a lot of terms in chemistry, and you probably have heard these from your science classes before. I'll get a different color here again. Atoms and elements. What really is the difference between those? And that's what we're going to explore here. Let's start with atoms. Atoms are essentially the smallest building blocks of matter. Right? So all matter is made up of atoms. Essentially, an atom itself is made up of certain parts. It has a nucleus, which would be right here. And inside the nucleus, you'd have protons, these positive charged things here, and neutrons, which have no charge. And on the outside of the nucleus, in these what are called orbitals, you have electrons. And those electrons are kind of hanging around. Okay, now this particular model that you see here is a Bohr model. It's a two-dimensional model representation of an atom. But we know, and you may not know, but you'll learn that atoms are not two-dimensional. And most things in life aren't two-dimensional. We live in a three-dimensional world. So this picture that you see here represents that three-dimensional atom that we would refer to. Now, when I draw something on paper, if I was going to draw an atom, it's very difficult to do three-dimensional on a piece of paper because paper is two-dimensional. So I'm going to use Bohr diagrams sometimes. It's very rare that you're ever going to have to draw this, but at least it gives you an idea, right? See how the orbitals are going in different directions? Whereas here, the orbitals are kind of all in the two-dimensional plane. A little bit of a history lesson here, kind of an interesting story. Where does the term atom come from? Where does that term come from? Well, atoms are actually a term coined by a man named Democritus, and he was a Greek philosopher. And essentially, the term atom is Greek for the smallest part of something, which makes sense, right? Because we said at the beginning that atoms are the building blocks of matter. And if they're the building blocks of matter, then they're like the smallest parts. They're like the little individual Lego pieces that you would use to build bigger Lego structures. Okay, so they're the smallest parts. Unfortunately, back when Democritus was alive, which was a few thousand years ago, he didn't really have a lot of technology. It was more based on philosophy. So what he did, and this is a story, I'm not sure if it's true, but it's a story. It's, history has a lot of stories involved with it. He took a clay pot and he smashed it on the ground. And he said, okay, this clay pot is not the smallest part. He threw it on the ground. He broke it into pieces. He took one of those pieces and he smashed it again. Got smaller pieces. He took those pieces and he ground them into the finest powder he could get. And that is what he called an atom. Obviously not the case. But at the time, in the Greek world, that was the smallest they could make something. And so that's where the term came from. Atoms we know now are much smaller, and in later units we'll talk about just how small they are. So that's an atom. They're the smallest individual units that you can use to build matter. Let's talk about what an element is. Well, you've all seen the periodic table of the elements. So what is the difference then between an atom and an element? Well, if I just quickly go back to my slide here on atoms, notice that there are protons in the nucleus and electrons floating around. Let's go back to the periodic table. Well, it just so happens that every one of these elements on the periodic table, I'm not going to check mark them all, but you get the idea. There's 1 through on this particular periodic table. There's 114. Okay, but these are the elements. Well, it just so happens that every one of these elements is made up of a different type of atom. Okay, so in other words, let me give you an example. Hydrogen, element number 1, has 1 proton. So any atom that only has 1 proton is a hydrogen atom. See if you guys can catch on. Helium is element number 2. So it must have, I feel like we're playing Dora the Explorer here. I'm like going to pause and you guys are going to answer, but I can't really hear if you're answering. That's right, guys. You got it. 2 protons. Okay? Element 114 must have, here we'll do it again, 114 protons. Okay, so each different element is made up of a different type of atom containing different numbers of protons. Now, an element, in terms of what we're talking about here, atoms are the smallest units of matter. Elements are made up of atoms of a particular type. Okay, so in other words, hydrogen is made up of elements that contain only atoms, that contain only 1 proton. Helium is made up of atoms that only contain 2 protons, and so on and so forth. But when you take 2 or more elements and combine them, then you can start to make different things. Okay? So atoms are the smallest unit of matter, and elements are all of the atoms of a particular type. As I said before, Democritus was wrong. There is something smaller than those grains of sand, and in fact, unfortunately, there are things that are smaller than an atom, and that's where we come up with the subatomic particles, okay? So sub meaning underneath the atom. Okay, so if I was in a column, so you see how I have these folders up here. I'll click on that. So underneath File, I have all these subcategories. They're underneath. See that? Edit, same thing, all these subcategories. Well, underneath the term atom, we have these other particles. They're called subatomic particles. We have the electron, we have the proton, and the neutron. I talked about those a little bit earlier. Now, why are these important? Well, because they make up the atoms themselves. And based on the numbers of these things, the atoms can have different properties, physical and chemical properties, like we talked about before. So they're all important, they're all connected. An electron, for instance, has a -1 charge. The symbol that we use for an electron is E with a superscript minus, so E with a little minus kind of at the top. Now, electrons have no mass. That is to say, the mass is so small compared to the protons and the neutrons that we might as well call it 0. It actually does have a mass, but it's so small compared to the other things that it doesn't matter. Right? So it would be like comparing, so take the mass of a blue whale, the biggest animal on planet Earth right now, and compare that mass to a flea. The flea's mass would be so small compared to the blue whale that if the flea was on top of the blue whale, it wouldn't matter, right? You wouldn't be able to measure that difference. Right, so we say that the mass of the electron is actually negligible. We assume that it's 0. It's not technically 0. We'll talk about that later on. But it's so small it doesn't matter compared to these guys. Protons have a +1 charge, and there's 2 symbols for protons. You'll see me use both of these in class. There's a P with a superscript plus, or, believe it or not, a hydrogen symbol with a superscript plus. Because we said hydrogen atoms only have 1 proton. Well, if you take away the electrons and the neutrons from a hydrogen atom, you have a proton. And that's where that comes from. And they, of course, have a mass of 1. Neutrons, on the other hand, have no charge. That's where the neutral, neutrons, kind of no charge. We're going to use this. This is just kind of my symbol. You wouldn't go around using this in other places. It's kind of my symbol. Unfortunately, this gets used a lot. So once we get the hang of this, we don't really need to. We can just write the word neutron, maybe. And mass units, again, for neutrons is a 1. Okay, so what does that mean? Well, what that means, therefore, the mass of an atom is going to equal its protons plus its neutrons. And an atom's charge, notice we talked about this here, electrons have a -1, protons have a +1, is based on the difference between the number of protons and electrons. Let me give you an example. If an atom has 10 protons and only 9 electrons, then that atom will have a +1 charge. Similarly, if an atom has 9 protons and 10 electrons, then the atom will have a -1 charge. Okay? That's how it works. Let's just go back for a sec. I'm going to take you back here to this atom. All right, so let's just go based on what we can see here, and let's try and calculate the mass of this atom. So I can see 1, 2, 3, 4, 5, 6 protons, and I can see 1, 2, 3, 4 neutrons. All right, so if I have 6 protons and 4 neutrons, then what is the mass of that particular atom? What's 6 plus 4, guys? You got to be able to do that in your head if you're going to take this class, just FYI. All right, you got it, I hope. 10. Okay, so the mass of an atom is equal to its protons plus its neutrons. Moving right along. How we can represent this information in a neat, handy-dandy little way is called chemical notation. So we've got this chemical notation, and basically what it does is it allows you to use the symbol of an element. Okay, so here it is here. This X is not a symbol of an element. However, you would replace the symbol from your periodic table. So if this was hydrogen, then I'd put H. Okay? Up here, we have the mass number. All right, so that may be given, it may be on the periodic table. It depends. Okay, but for hydrogen, the mass number is 2. All right, so this A represents the mass number. Now, what the heck are nucleons? Nucleons are just particles that are in the nucleus of the atom, and so that would be protons and neutrons. Okay, so we know that the mass number equals the protons at the neutrons. Now, the atomic number, which is always found on the periodic table, for hydrogen is 1. All right, so let's say we know hydrogen has 1 proton. Well, if it has a mass of 2, and it only has 1 proton, how many neutrons does it have to have? Yeah, it has to have 1 neutron. Okay, so let's look at this all together, right? What can we tell from this? We can tell from this that we have a mass of 2 and an atomic number of 1. We can tell from this also, because the atomic number always equals the number of protons, that we have 1 proton. And because all elements, as they're written on the periodic table, are neutral, which means they have no charge, we can also say that this particular element has 1 electron. 1 neutron, 1 proton, 1 electron, mass of 2, and an atomic number of 1. And there's your chemical notation. This is just a generic, okay? And that sums up the basics of chemistry. This should help you finish, if you're in Chemistry 11, it should help you finish Assignment 1. If you're in AP Chemistry, you should be taking notes on this, and we'll definitely be reviewing and discussing this in class.